What if the next major transformation in ground warfare isn't a new tank or a new rifle, but a machine that can operate alongside a soldier? Imagine a US Army unit moving through a battlefield while autonomous systems scout ahead, monitor the terrain, and provide information to the soldiers behind them. The soldier is still making the critical decisions, but now he has machines doing some of the most dangerous and repetitive work. That future is already being tested. At Fort Hood, Texas, soldiers from the Iron Horse Brigade, part of the 1st Cavalry Division, have been field testing autonomous systems through Project Overwatch and the broader Pegasus Charge Innovation Initiative. The goal is not simply to demonstrate futuristic technology, but to figure out how these systems can actually improve the way soldiers operate in the real world. The reason this matters is that modern battlefields are becoming incredibly crowded with information. Drones can see from above, sensors can monitor movement, satellites can provide intelligence, and electronic systems can detect signals across enormous areas. The problem is that humans can only process so much information at once, especially when people are also trying to move, communicate, and survive. This is one reason drones have become so important in recent conflicts. A relatively small unmanned aircraft can provide reconnaissance, identify potential threats, and help units understand what is happening beyond the immediate line of sight. But as more systems enter the battlefield, the challenge becomes managing all of them without overwhelming the soldiers who are supposed to use them. This creates what could be called a human bottleneck. One soldier can operate a radio, watch a screen, control a vehicle, or analyze information, but doing all of those things simultaneously becomes increasingly difficult. Autonomous systems could help by performing certain tasks themselves, allowing humans to concentrate on decisions that actually require human judgment. And there is an important difference between a remotely controlled machine and an autonomous one. A remotely controlled system may require an operator to continuously tell it where to move and what to do. An autonomous system can potentially navigate, monitor its surroundings, or perform predefined tasks with less constant human input. That distinction could fundamentally change how military units operate. Instead of having one soldier assigned to one machine, a single operator could potentially supervise multiple autonomous systems at once. One could provide reconnaissance, another could carry sensors, and another could help monitor an area, while the soldier remains focused on the broader mission. But technology alone doesn't create military power. A robot can have impressive sensors and software, but if soldiers don't understand how to integrate it into their operations, it may become little more than expensive equipment. That is why exercises like Project Overwatch are important. The Army is testing not only the machines, but also the people, tactics, procedures, and networks that connect them. The larger concept is known as human-machine teaming. The idea isn't necessarily to replace soldiers with robots, but to give soldiers additional capabilities without requiring a matching increase in manpower. In simple terms, the machine handles more of the sensing, scouting, or repetitive work, while the human remains responsible for judgment and mission decisions. And this may be the real revolution. The future battlefield may not be about humans versus machines at all, because the most powerful combination could be humans working with machines as a single fighting system. The soldier doesn't disappear from the battlefield. The soldier gets more machines around him and potentially far more capability at his fingertips. The next step is not simply giving soldiers more machines, but allowing them to control and coordinate those machines as part of the same battlefield network. Imagine a soldier receiving information from several autonomous systems through a single interface instead of operating each platform separately. That could allow a relatively small unit to see farther, react faster, and cover more ground without putting more people directly in harm's way. The biggest advantage may ultimately be scale. Humans are limited in number, while autonomous platforms can potentially be produced and deployed in much larger quantities.
If these systems become cheaper and more reliable, a future army unit could operate with a large number of unmanned platforms without needing an equal number of additional soldiers to control them.
That could also change the meaning of risk on the battlefield. An unmanned system can potentially be sent into an area where placing a human would be extremely dangerous. It could scout a suspected position, monitor a route, or investigate an uncertain situation before soldiers move forward. The machine may be expendable in a way that a human soldier never can be. But autonomy also creates a completely new set of problems. What happens when a machine's sensors misinterpret what they see, or when its communications are disrupted? The more responsibility given to autonomous systems, the more important it becomes to establish clear limits on what machines can do and where human control must remain. Electronic warfare makes the problem even harder. An adversary could attempt to jam communications, interfere with navigation, or manipulate the signals that autonomous systems depend on. So the future battlefield won't simply be about having more robots. It will also be about keeping those robots connected, reliable, and useful while an enemy is actively trying to disrupt them. Artificial intelligence could help solve part of the information problem. Instead of forcing soldiers to examine dozens of feeds themselves, AI could help identify unusual movement, prioritize potential threats, and highlight information that deserves human attention. But that doesn't eliminate the human decision-maker. It changes the human's role from processing everything to deciding what matters. This means the Army's biggest challenge may not actually be building the machines. It may be integrating them into everything else the military already uses. Autonomous systems have to work alongside infantry, armored vehicles, artillery, aircraft, communications networks, electronic warfare systems, and intelligence platforms without creating a completely new layer of confusion. That points toward a broader shift from platform-centric warfare to network-centric warfare. For decades, military power was often measured by the number of tanks, aircraft, ships, or other major platforms a country possessed. Increasingly, the more important question may be how effectively those platforms, sensors, humans, and autonomous systems can share information and operate together. And that brings us back to the soldier. The future U.S. Army probably won't be a battlefield without humans, because machines still struggle with context, judgment, ethics, and unpredictable situations. Instead, it could become a battlefield where humans sit at the center of increasingly large teams of machines, directing systems that can see, move, and operate across a much wider area. That's why exercises like Project Overwatch are worth watching. The real experiment isn't whether the Army can make a robot move. It is whether soldiers can turn autonomous technology into an actual battlefield advantage. The future may not be man versus machine, but man with machine. And if the Army gets that combination right, one soldier could eventually command capabilities that once required an entire team.